Hello, my name is Eli, and my group mates are Nikhil and Michaela, and this is our absorbance and fluorescence experiment.
So the purpose of this lab was to perform an investigation into the nature of absorbance and fluorescence along with the relationship between the two using spectrophotometry. We found that the absorbance of light in a solution can be found by taking the logarithm of the ratio of initial intensity of light to the ratio of the light after passing through a solution. We found that certain molecules absorb light at a certain wavelength and then emit that light out at a certain longer wavelength.
In this lab, we tested two experiments, one with dye and one with fluorescein. In the dye experiment, we looked at how much light from the source is transmitted once it traveled through the dye, by determining the absorbance that occurred. The absorbance occurs as the dye molecules absorb and retain the energy in the system. For the fluorescein experiment, we also determined the amount of light absorbed by the fluorescein molecules, and also found the intensity of light that was fluorescent from the liquid. The fluorescing light comes from electrons going from excited states back down to ground states. The falling of these electrons causes a release of energy in the form of fluorescent light.
Our experimental procedure consisted of two experiments. The first one was to identify and calculate the absorbance of an unknown dye solution. We did this by shining a laser 60 centimeters away from a cuvette filled with water with a spectrophotometer on the other side to record the intensity data. We did the same thing but with a cuvette filled with an unknown dye. From there we created absorbance spectra and compared it against known spectra to identify the dye. We used the extinction coefficient of the identified dye to calculate the concentration using the given formula. For the second experiment, we created an absorbance and fluorescence spectrum for fluorescein. We did this by using the same method for experiment 1 to create the absorbance spectrum. In order to create the fluorescence spectrum, we did the same setup as experiment 1, except this time we placed a spectrophotometer on the right next to the cuvette at a 90-degree angle, so only it absorbed emitted light from the dye. We did this in a dark room and used the data to create a graph of the fluorescent light on the same graph as an absorbance graph.
We exported the data from the program in order to find the absorbance of the light from the dye. This was done by taking the log of the initial intensity of water divided by the intensity of the dye. The absorbance spectra of the dye matched up to the absorbance spectra of the Lapidus dye. We exported the data from the fluorescent and found the absorbance again, using the log of the intensity of water divided by the intensity of the fluorescent. The emission graph was also scaled down by 50% in order for the graphs to be compared. Spectroscopics are able to identify an unknown sample using an absorbance spectra, which is done by comparing the absorbance of the unknown sample to the absorbance of the known sample. In order to find the concentration, we use Beer's law, which is concentration equals the absorbance over the extinction coefficient times the length of the cuvette. The concentration of the dye was 4.19 times 10 to the negative 5. Absorption spectra shows where the light has been absorbed, while emission spectra shows where atoms have released photons in that wavelength. Absorbance and fluorescence are both used to identify chemicals, but absorbance is used to solve for concentration. The wavelength of the photon going in is different than the wavelength coming out because the photon emits at a lower energy. This means that the emitted photon has less energy, causing the photon to come out as a higher wavelength. Energy is conserved but has been converted into vibrational energy. The light source has to be at a 90-degree angle so that the direct light was not an added component. The room must be dark so that there is no other light hitting the spectrophotometer.